Rotations are probably the trickiest transformations to do by compass. And the reason for it is, like in this case, I'm doing a rotation centered at the point P of 90 degrees. And the thing I'm rotating, my pre-image, is triangle ABC. What's difficult about that is the fact that if I know it's rotating 90 degrees, I need to be able to make sure I create an angle that is exactly 90 degrees. And remember, the way we do that with a compass is with a perpendicular bisector. So before we get started, remember that rotations are always counterclockwise unless you're told otherwise. So I know that this triangle that is shaped like this is going to rotate 90 degrees and will be pointing that way. So the first thing I want to do is kind of reminiscent of our dilations. I'm going to draw a line segment that goes from A through P, but this time I'm actually going to extend it and go a little bit past P. And the reason is I want to create a line that is perpendicular to the one I just drew. So that way I can take that point A and place it on that perpendicular line. So what I need to do is I need to create a line perpendicular to this one that passes through the point P. And if you recall, the way we do that is to center our compass on the point we're trying to go through. And I need to make 2 points that are equidistant from P on either side of it. It doesn't matter how far I set my compass here, as long as once I choose a length on one side, I keep it the same on the other. And now I've got a line segment here where P is the midpoint. So I'm going to draw the perpendicular bisector of that. I center my compass on one side, stretch to the other. I make an arc above. And in this case, I don't really have to go below because I know that the other place my line is passing through is P. So I can kind of cheat a little bit. And draw this arc. And then line up between that point of intersection and P. And again, I'm just going to draw a light line. And as you see, this one is now perpendicular to the one I drew before. So that means A has to lie somewhere on this perpendicular line. I knew to draw it over here because I know that my rotations are counterclockwise instead of going down that way. So all I have to do is, since A is originally this far away from my center of dilation, it has to be exactly that distance away on that perpendicular line. So that there will be my A prime. And now I repeat for all of the other vertices in this triangle. I start by drawing a line segment that goes from my center of dilation to my pre-image point, and I make sure I give myself a little bit of room on the other side of that center of dilation. I place my compass on that center of dilation where I'm trying to make this perpendicular line pass through. I make an arc on one side and an arc of the same length on the other. And now I draw the perpendicular bisector of that line segment. I measure across. I draw an arc above. And then I go above on the other side as well. So this line I'm drawing in is perpendicular to the one from P to B, meaning B prime has to lie somewhere on it, and it has to be the same distance away from that center of rotation that P was. So I measured to B. I just drew an arc up there, and I place my B prime. And lastly, we'll rotate C around. Center at my pre-image. Draw a line that goes through my center of rotation. I get my compass, and I draw an arc on either side of it. One here, one there. And then I draw the perpendicular bisector of that line segment I just created. One arc goes up here. The other one over here. I connect the two. Ooh, missed it a little bit. Let's go back and erase that. It's okay to erase our mistakes. We just want to make sure that our compass arcs are still on the paper. And then I figure out how far C is from P. And I say it's got to be exactly that same distance away on that perpendicular line. And that there will be my C prime. So I connect all of my image vertices together in order to create my rotated triangle. Remember that since a rotation is a rigid motion, these two triangles should be congruent. So I want to compare their shape, make sure there's nothing wonky going on there. Maybe I placed a point in the wrong space. Now realize that whenever you have a rotation, you've got a lot of these lines and a lot of arcs there. So just to show to you, so it's clear, that there was my pre-image triangle. And up here, that's my image triangle. Now, we have different techniques for different angles of rotation. 90 degrees, we draw that perpendicular bisector. If we were asked to draw a rotation centered at P of 270 degrees, well, the trick is exactly the same, except all I would do is rather than make that perpendicular line going up here, I remember that 270 degrees counterclockwise is the same thing as 90 degrees clockwise. So I would just make that perpendicular line go on the other side of my center of dilation. And then I would just measure all of my points and just make sure that my image points are the same distance away. So that would be where my A prime would be if it were a 270 degree rotation. And I could repeat that for all of them to make sure that I have a 270 degree rotation.